So in our series on factoring polynomials, we've seen different methods to factor polynomials based largely on how many terms the polynomial has. Now, when you get to your homework or maybe even your test, all of your polynomials will probably be mixed up. And so you're going to have to recognize which strategy to use when you're factoring. So this video is going to talk to you about some strategies to look for when you're factoring polynomials. Now the first thing we've been trying to train you to do always is to look for a GCF. So even if you are not reminded, you need to get yourself trained to do so. So I'm going to skip around here as I do some of these examples, and you're going to see us use several of the methods that have been featured already in their own videos. So look at the first example. It says factor completely. Notice that's all it says. Those are your only hints. So the first step will be always to look for GCF. And in this particular trinomial, we know that the 5x to the 6 is a GCF. Then we're going to divide the 5x to the 6 in every single term. So that's going to leave us here with 4x to the 11. And then I'm reminding you again that with our powers of x, this is product rule. So the 6th exponent added to the 11th should give us that 17, right? So that's how we do that. So that comes from our product rule. And then here we get, in our middle term, we get 2x to the 5th. And in our last term, we get 3. Now normally at this point then we would count the number of terms in that parentheses, which this is a trinomial. All right, but this trinomial does not factor further. It's not one of our quadratic trinomials. So this particular problem is complete, and the only thing that we needed to do with it was to factor out a GCF. As opposed to, let's look at number 2. These are your quadratic trinomials with our leading coefficient not equal to 1. First of all, we notice that a GCF is 1 of all 3 terms. And so this is a trinomial. And then a does not equal 1. So this is where I would have you go look at your notes to try to decide, how do I factor trinomials where a does not equal 1? Now these are the trinomials where we gave you several options. And I'm going to show you here the bottoms up option. But remember, you can use the AC method, you can use trial and error. So in the bottoms up option, we kept track of what A, B, and C were, and the first step was to multiply A times C, which in this case gives us 3 times 10 or 30. And we also know that our sum is going to have to be B, so that's negative 11. So we're going to look for 2 numbers that multiply to a positive 30 and add up to a negative 11. And so if they're going to multiply to positive but add up to negative, we know that those are 2 negative numbers. And so we're going to use negative 6 and negative 5. And then here's where I told you to take your A, divide by A. This is the step that a lot of students miss, okay? And I like to do it right here. So I'm going to divide by 3. I'm going to make these fractions and then reduce. So then this first fraction does reduce to negative 2, but the second one does not. So leave it alone, and now let's put here our parentheses. And in the first parentheses, we're going to write x and then minus 2. That came from there. And then in the second parentheses, this 3 is going to come up. It's called bottoms up because the 3 from the bottom of this fraction goes up to meet the x. So 3x minus 5. Now, if you're doing these problems and it's a test, I recommend you check them, and you can check by FOIL. And so let's do that real quick. So that's 3x squared, outers are negative 5x, insides are negative 6x plus 10, and there's our negative 11x, so that's definitely checks. And so here is our answer. I'm actually taking a look at those binomials just to make sure that they don't factor further, and they do not. So again, we looked for a GCF, we counted the number of terms. It's a trinomial with a not equal to 1, and so then we chose our method on how to factor. Let's go to the next one. Okay, here we have a binomial, so 2 terms. GCF is 5x, so our first step will be to divide that out, factor that out, and we have x squared minus 121. Okay, beautiful. Now, with the binomials, Remember, there are 4 different binomials for you to keep track of. Let me remind you of what those are. So here are our 4 binomials that you have to keep track of. The difference of squares, the sum of 2 squares, the sum of cubes, and the difference of cubes. Okay, so you have these in your notes, right? Let's go look and see what binomial we have in our problem. And this binomial is a difference because we have a subtraction. And so it's either going to be a difference of squares or a difference of cubes. And the x squared is a big hint, isn't it? So this binomial is the difference of squares. So since we recognize it, we know that that means we need conjugates. And so we're going to bring down the 5x. And then what did we square here? We squared an x and we squared an 11. And one's going to have a plus and one's going to have a minus. And taking a look at my final answer there, none of those factors factor further, so I am done. So did you see how we counted the number of terms, then we narrowed it down because of the middle sign to be a difference, and it could either be squares or cubes, but it had to be squares because we have x squared and of course 121. Let's try the next problem. Okay, this problem is also a binomial, isn't it? And our GCF is 1. Okay, and it is a difference again, so we have a difference, and we just looked at those. These could either be difference of squares or difference of cubes, and because we have that x cubed there, and do you recognize 8 as 2 cubed? And do you recognize the 125 as 5 cubed? The more you practice, you're going to see that the same numbers keep being repeated, right? So we definitely have here the difference of 2 cubes, which means at this point, did you memorize the pattern? Now, if you haven't yet, go back to that video on sums and difference of cubes because I explained the pattern there, but we're about to do it here. If you recall, we're going to have a small parentheses that houses a binomial and then a larger parentheses that houses a trinomial. And in the binomial, we take these cube roots, these numbers that got cubed to give us our original binomial, and that's 2x. And then again, a reminder to you that these signs are going to match in the binomial. The original problem and the binomial, those signs match. Then we're going to build that trinomial from the binomial. So we square this guy. So that's 4x squared. Got to be really mindful to square the 2, right? Okay, because that's what students forget. Then our middle sign is opposite. So we put a plus this time. Here we have the product of 2x times 5. So that's 10x. Then this sign is always plus. And finally, we square the 5. We square the 5 for a 25. Now, as I look, the binomial does not factor further, and this trinomial will not factor further, by the way. Unless you forgot a GCF, the trinomial will not factor further. Now, sometimes the binomial factors more, so you want to take a look at that. So that's our final answer. And again, I went through that pattern really fast, but that's because we have that other video. So go back to that other video if you need it. Okay, we're running through these quickly just to give you ideas. Okay, problem number 5 is a trinomial. There are 3 terms, but there is a GCF. So the GCF is 3w squared. So we're going to factor out 3w squared. That leaves us with w squared minus 5w minus 36. So w squared minus 5w minus 36, which is a trinomial, right? With a equal to 1. So remember that the trinomial with a equals to 1, this is the one that's pretty easy. We look for 2 numbers that multiply to the negative 36. So the product is the constant, it's c, so that's negative 36. And the sum, the 2 numbers have to add up to the middle term, negative 5, to b. So 2 numbers that multiply to a negative 36 and add up to a negative 5 are negative 9 and positive 4, aren't they? So we're going to write 3w squared, w minus 9, w plus 4. And be super careful that you are using w, not x, especially if you're using an online homework tool, so that you don't get it marked wrong. Okay, and I'm looking at the binomials. They look good. They don't look like they can be factored further, so this is our final answer. Again, if I'm in a test, I would check this, and how I would check that is I would FOIL the binomials first and then distribute the 3w squared. Let's go to the next one. We're going quickly here because these are all review, aren't they? All right, I've got 4 terms. Now, we haven't done one of these for a while. So I have 4 terms. I'm looking at the 4 terms and the GCF is 1. And with 4 terms, we use grouping method. Remember that? So we're going to use the grouping method, which means we're going to group these 2 and 2, and I'm not liking the order, are you? Let's rearrange. Let's rearrange some things. Let's put the x squared y. How about if we put the x squared y with the other x squared? The 5x squared. Ha, there you go. I'm being sneaky. Plus, and then I'm going to put the 7y with the 35. So rearranging is allowed, if you remember, and then the grouping allows us to group the first two with the last two, leaving the plus behind. You always leave that plus in between the two groups. And if there's a minus there, I'm just going to remind you that you tuck that in with the 7. If there had been a subtraction sign there, we would put that with the 7. But it's a plus, we're good. Now you're going to look for GCFs, okay, for the grouping method, GCF of each group. So here it's x squared, which leaves us y plus 5. And then in the second group we have 7, which leaves us y plus 5. And with the grouping method, just a reminder that you know you're on the right track if these binomials here match exactly. Because the goal is to get those two to match, because now that is the GCF and you bring it out. So y plus 5 times x squared plus 7. And as I look at those two binomials, they are simple. They're prime now at this point. No more factoring. So that's our answer. So did you remember the grouping method? Because a lot of my students, they've gotten rusty on it by the time I reach this section. Okay, here we have a binomial with a GCF of 3y to the 4th. So 3y to the 4th comes out, gets factored out. Then we are left with what? Y cubed plus 64. Have we seen that before? Do you recognize that binomial? Y cubed plus 64. If you said sum of two cubes, you're absolutely right. Sum of cubes. That's that one with that pattern, isn't it? Okay, here comes the pattern. Now remember, small parenthesis binomial, large parentheses for the trinomial. And in the binomial, you take those cube roots, right? You match the signs. Y plus, and what did we cube to get a 64? If you said 4, you're right. So y plus 4 in the binomial. Then you build the trinomial. So again, you're going to square here. So that's y squared. Opposite sign. So that's a negative. Product. So that's 4y. This one's always plus. Always. I'm going to put always. And then square. And that's 16. Does anything factor further? No? Okay, that's our answer. That's our answer. Very well done. Are you starting to get it? Yeah. Okay, this one's a trinomial with a GCF of 5x. So GCF 5x. There we go. So we're going to factor that out. We've got x squared plus 8x plus 16. Okay, it's a trinomial. It's one of the easy trinomials. A is 1. Leading coefficient 1. We like these because we're looking for two numbers multiply to 16 and add up to 8. And if you said 4 and 4, you are right. This is a perfect square, isn't it? We're getting two of those. Yep, perfect square trinomial. But we just went ahead and factored it without using the perfect square formula because it was kind of an easy perfect square, right? With the a equals to 1. So you can give your answer like this, or you can give your answer like this, and they are both equivalent. What about this one? Do you recognize it? Binomial. Do you see the squares? Those squares are kind of staring us in the face, aren't they? This is the difference because we have that subtraction of squares. So this is the one that uses the conjugates again, right? Do you remember? One's going to have a plus and one's going to have a minus. And what did you square to get 36x squared? Yep, 6x is right. And what did you square to get 81? 9. Oh my goodness, what do you notice? Yep, if you said you noticed there that this factors furthers, you're right. You know what that means, right? That means we forgot a GCF. I got so excited with seeing the squares that I forgot a GCF. And what's the GCF? Can you see it now? Yep, it's a 9. You're absolutely right. So at this point, I'm going to show you both methods. If you got this far, then I'm going to take out a 3 GCF from this first conjugate here. And then I'm going to take out another 3. Do you see that? From this second conjugate. And so then I'm going to put the 3's together, and there's our 9. Okay, so there you go. This is what I mean by always check your final answer to see if it factors further. But now I'm going to show you the way we should have done it. This would have been so much better if I hadn't gotten so excited. and just factored out the 9 first, which would leave us with 4x squared minus 9. You see that? And now this binomial is still the difference of two squares, isn't it? It's still the difference of two squares, so we still have 2x plus 3 and 2x minus 3. And of course, we knew we were going to get the same answer. But I want you to see the two different ways to do the same problem and how important it is to check for a GCF first and last. First step and last step, because if you don't catch it one place, you may catch it the next place. And sometimes you'll need two. You'll have GCF at the beginning and then more factoring at the end. So you always want to check. Well done. Okay, let's do next. I'm looking at this trinomial and it has some really big numbers. So I'm a little bit scared about doing bottoms up with it. First of all, as I look through, I notice that my GCF is 1. So no prayer of making these numbers be smaller. And if I needed to do bottoms up on this or AC method, I'd need to multiply 25 times 144, and that is a big number. So here's the thing. Let's put on our thinking cap and kind of really look at these numbers. And do you notice anything about those numbers, the 25 and the 144? Do you recognize them? Yeah. Do you recognize them as perfect squares? Yeah. Let's see if could it possibly, so this is our guess. This is our guess. Is this a perfect square trinomial? We're going to check for that. Perfect square tri. We're going to check for that. Because if it is, then we know how to factor it and we won't have to do those big AC method or bottoms up with that huge number, right? So how it works, let me remind you. What did we square here? We squared a 5x, okay? And what did we square to get a 144? We squared a 12. And we have to check the middle term. So the middle term would have to be double these two terms multiplied. 5x times 12x, so which is 60x. Okay, that's what we're checking. And so 2 times 60x is 120x, isn't it? These match. What does that mean? That means that we do have a perfect square trinomial. Yes, we've checked that, which means that we can just factor as a square 5x plus 12. So we're just using those numbers here. And again, if you need to see more examples of this one's a tough one to look for this pattern, then go check out the video on perfect square trinomials so you can see more examples. Okay, problem 11, we have a GCF. It's a trinomial, but I can see the GCF, can't you? Yep, I'm thinking what, 5? There's a 5. Okay, so let's factor out the 5, which leaves us with a 3x squared minus 7x minus 6, which is a trinomial with a not equal to 1. So that means we're back to deciding on whether we're going to use bottoms up or AC method or which method, trial and error. Okay, and I'm going to stick with my bottoms up because my students seem to like that one the best. So again, we're going to multiply a times c, which is a negative 18, and then our sum has to be negative 7. And I need two numbers that multiply to negative 18, and they have to add up to a negative 7. And I'm thinking negative 9 with a positive 2. How about you? Negative 9 with a positive 2. And then you want to put your a, just going to remind you, put your a here. Make a fraction with a. That's the part the students forget. Okay, fraction with a. Reduce. And so this is negative 3, and then we have a 2/3. Okay, so bring down the 5. Don't forget that. But in our first parentheses, we're going to write x with the minus 3 from here. Okay, and then in our second parentheses, this 3 that's in the bottom has to come up. With the x. 3x plus 2. And I'm going to take a look at these binomials, and nope, they do not factor further. So there is my answer. Okay, how are you doing with that bottoms up? Or whatever method you use. I'm sure your teacher does not mind, so you pick one that you can use consistently, okay? All right, here's our very last problem. I promise. Oh boy, 4 terms. Okay, so we have 4 terms with a GCF of 4w. So 4w, 2w squared plus 4w plus 3w plus 6. Okay, now we have a choice here. We could add together those middle terms and then deal with this as a trinomial, or we could just do grouping method. So since we haven't done too many grouping method ones, let's try that one. Just going to practice, but you do have a choice. So with the grouping method, we're going to group, I like the order these are in, the first two and the last two. Colors really help. And then we take out GCFs from each group. So from this first group is a 2W, which leaves me with a W plus 2. And from that second group is a plus 3, which leaves me with a W plus 2. And again, you know that your grouping method is going well when these two binomials match, which is now you're going to factor out that W2 with and bring it out with the 4W. So W plus 2 goes out here, and then that leaves you with the 2W plus 3 inside the parentheses, and none of these factor further. So there is our answer. So I hope that's helped. Again, just a short recap. Look for GCF first. Count the number of terms that are left, and from those number of terms, whether you have a trinomial or a binomial, you should now know different methods on how to tackle. And then always check your final answer to see if you've left any extra factoring out or whether we can go further. Checking is always an option, of course. So, good luck.